Today we're going to be talking about everything you need to know about Swift. What the heck is an environment? It's the place where you write the code, build the code, compile the code, and do all that kind of stuff. And so for Swift, the main one that we use is Xcode. So if you want to open up Xcode, there's a few options that you can have here. So one of them is going to be create a new Xcode project. This is where you can create an application, a game, or a Safari extension, and many other things that you want to do to your heart's demand. In addition to these, you can also create what's called a playground, and that's what we're going to be messing with today. So in order to get to that, you go up here to the File, New, and then you open a playground. And a playground is basically where you can build and run your code without worrying about a lot of the bulk, whether it works on iPhone, iPad, Mac, and all the kind of jazz. This is just pure Swift. If it runs, it runs. And so if you're getting started with Swift, this is where I generally direct you to because you see the results immediately. Creating a variable is incredibly easy. All you say is var, and then you put in your variable name, and then you set it equal to something, whether it be a string, an integer, a class, or really whatever. Now moving further along, you can also assign a type to it. So let's say I only want this to be a string. That's where I would do it. So I'd say colon string, and then you'd set it equal to that. That way, if I were to assign this to a number, then it would actually throw an error saying this is incorrect. I expect a string here. And then there's also something called a let variable. So this is going to be, let's say my let name will be equal to a string, like so. The reason we have these two differences is variable name can be changed later on. So I can say variable name will be equal to something else. And if I built and ran that, it would change this variable to something else. But if I were to do the same with a let name, it throws an error because this variable cannot be changed after the fact. Arrays are just a collection of variables. So if we say my array will be equal to, and then we want this to be 2, 3, 4, 5, all of these are different variables. So if you wanted to, we could also say var number 1 will be equal to 1, and then we can put that right in here. Now one thing to note with an array is all of the types of each item in the array have to be around the same. Now we could talk about this a little bit later, but if I were to put in here a string, it would then fail. But let's say I have this array and I want to add something to it. You just say array.append a new element. So now we can append, let's say, the number 6. That's going to add the number 6 to our array. Now let's say I have another array here. We can easily add that to that first array if we wanted to by saying array.append, and then you say a contents of, and then array2. That's what that would do. It would just take the last elements and pluck it right onto the end of the previous array. Now there is another way that you can do this. You can say array plus equals, and then you can say array2. That's just a shorthanded way of doing it. Now, in addition to an array, there's also something called a set. So let's just make sure that we're making this a set will be equal to, and then we can say 1, 2, 3, 4, 5, 6, and so on and so forth. Now, what's the difference between an array and a set? Well, as you can see, so with an array, it's all ordered. So it's 1, 2, 3, 4, 5. But as you see with the set here, I put it in as 1, 2, 3, 4, 5, 6, but it's all unordered. But the good part of using a set is it makes sure that there are 0 duplicates. So let's say, for example, I say set example dot, and then we insert a new member, and then this is going to be, let's say, 6. You will now see that it's only still going to have 1 6. It's inserted false because there's already a 6 there. So if you want to try avoiding duplication, set is kind of the way to go. But also, you lose order. So to give or take, you want to see what benefits you the most or not. Now, in addition to a set and array, you can also use what's called a dictionary. So we're going to say var dictionary will be equal to, and a dictionary is a comma-separated list of key value pairs. So what that basically means is, let's say this is the key. On the other side of this colon here is going to be the value. So if I already know the key, it's very quick and easy for me to get the value. So if I wanted to call that dictionary, we can say open close bracket here, and then this is where we're going to call the specific key, and it will print our value. And in terms of like the big O notation, making sure that we find things in the quickest way possible with the less usage of computation, right? This is where you would typically go for a dictionary, making sure that we can search for that value as fast as possible. All right, so now let's talk about structures, which are basically objects that hold multiple variables and functions. So again, very easy to create a structure. All we do is say struct example struct, and inside of here we can put our variables. You can also create, let's say, a function in here. We'll dive into functions in just a minute. You can also create a new struct inside of your structure if you really wanted to get crazy with it, right? Well, why the heck do we use structures? It's basically so that we can create an object that holds multiple variables and functions and whatnot. And so if we really wanted to use this, it's fairly easy. We just say let struct example equal example struct, open close parentheses, and then we can take our struct example dot example, and then we're just referencing this example right here, which is an empty string. So if we wanted to change that, it would then grab that something variable that we created here. We can even use this struct example dot example and change it to something else. We could do that if this wasn't a let. If this is a variable, we can do that. But let's say inside of our function here, we want to print print. And then we say struct example dot, and then we can call something from right inside of there. Then that's going to print right here. And then also, just because I programmed this and figured why not show it off a little bit, the way that we access this structure here is by going through the parent structure. So we say example struct dot something. And again, I'm going through, this is the parent structure, and I'm going to this child structure here. And then this now needs to be initialized, and we can say var example will be equal to that. And then if we wanted to access this variable, all we need to do is say example dot example2. Now, in addition to structure, there is another thing called class. And class is basically the same thing as a structure, but it's differentiated in the way that it maintains data. But in order to type a class, it's basically the exact same thing. So we could have an example class, and then inside of here we say var example will be equal to, let's say, a string. You know, it can be the exact same thing almost. It's just the way that we handle the data is different. Now, another thing that we can do to hold data is a tuple. So a tuple is essentially a structure just without any name. So the way that you write it is basically saying let my tuple equal, and then you say open close parentheses, and then inside of here you can put, let's say, a string, you can put a number, and you can put something else. Let's put our example structure, for example. This is a tuple. It holds all of these different objects, and there's really no assignment to any of these. It's just kind of there. But what you can do with a tuple is reference those specific items or elements here. So it's pretty easy. You just say tuple.0 or tuple.1 or 2. Again, this would be 0, this would be 1, and this would be 2, because that's just how kind of arrays and tuples and all they work. They start at 0. And so if we're to print out tuple.1, again, it returns 4. Now, also with the tuple, you can assign it names, for example. So let's say this is my first name. And so now if I want to access it, I can say tuple.firstname or tuple.secondname, and so on and so forth. And that's now how I would access that stuff. Now, something we haven't gone over yet is initializers. So initializers are very important when it comes to both structures and classes. So basically, when you create a structure, you might want to sometimes pass along certain variables. So in order to do so, all you say is initializer. We can put in here that I want to pass along an example string, and then we're going to want that to be a string. And now when we initialize this example structure, I can now assign this example to the example string that we passed. And so now if I were to say let example struct equal example struct, now if I were to put the initializer, it's requiring that I put example string. Now if you find this example string to be annoying in an initializer, you can put an underscore before that, and then it'll now require that this is only a string that's provided without any label attached to it. Sometimes just kind of helps clean up code. And you could take this a step further, and let's say I want this to only be name here, and now we assign the name, but I want there to be a different label when we do initialize it. Let's say first name, for example. Now if I were to create this, it's going to require the first name, but for this it's known as name. I don't use this too often, but sometimes other people do, so it's helpful to know why the heck they're doing it. So again, left side is for the initializer, right side here is for the inside of the initializer. Arithmetic operators also exist in Swift, and we'll just briefly go over them. So it's pretty easy. Again, it's 1 plus 1, 2 times 2, 4 divided by, let's say, 2. I'm adding spaces. You don't need to add spaces if you don't want to. but generally it's the exact same way that you would generally do it with a calculator, for example. But it's good to see that, this stuff can be done with code. The only one that is kind of interesting that you may or may not use, I have yet to use it honestly to this day, is this % sign. So this is going to give you the remainder of, let's say, 5 divided by 2. What's the remainder of that? And it's going to be 1. So 2 can fit into 5 2 times, but it leaves a remainder of 1, and that's what prints out there. And of course, these can be stacked onto one another. So if I wanted to do this, let's say 2 plus 1 divided times 10. And of course, all of this operates under PEMDAS. So essentially, if I were saying 2 plus 1 times 10, it's going to first do 1 times 10 and then add the 2. That's how that would work, and then it prints out 12. Now, in addition to all this math, we can also use comparison. So if we say if, let's say 5 is greater than 3, then we print out true, else we do not. If statements are completely unavoidable in programming, they're basically just check if something is greater than, less than, equal. It can be any of these things. So if 5 is greater than 3, then we print true. Otherwise, we're going to print false. Or let's say if 2 is greater than 3, then we're going to print false instead of true. That's how that works. You can also stack these, so you can say less than or equal, or greater than or equal, and then the exclamation point. So the exclamation point and then equal, this means not equal. Now another thing you can do is stack these. So let's say if 2 is greater than 3, and, so in order to say that is 2 ampersand signs. So if 2 is greater than 3, or let's say 4 is greater than 3 actually for this case, and let's say 3 is equal to 3, then we're going to print true, like so. You can also stack or. So or is just the 2 straight lines up and down, and then let's say 2 is greater than 4. So because these variables are true, it's still printing out true, even though this one is false. Now also in comparing things, you can compare structs to other structs. Now the way that you would do this is a little bit interesting. So we'll dive into it, but generally you could say example1 dot value is equal to example2 dot value, and if that's true, then we're going to print true, otherwise we're going to print false. And right now example 1 is set to 1, but right now example 1 is set to 2 and example 2 is set to 1 at the moment, so it should print false. And that is generally how you would compare a structure. You look for a certain data point that you want to compare inside of the structure. Now another thing you can do, if I say example 1 is equal to example 2, this is going to throw an error. But what you can do is set, so this right here is called a superclass. So you can add a superclass of, let's say, equatable onto this. But what equatable allows you to do is compare 2 structs together. Now this is easy right here with one value, but let's say we have multiple values. So this is going to have value 2 is equal to like a string or something like that. But in order to be true, we only really want to compare value 1. But the way that you would do this is say static func equal, and then we have the left hand side, which is going to be an example struct, and we have the right hand side, which is an example struct as well. So we have static func equal, left hand side example struct and right hand side example struct, and with this we want it to be expecting a return value of bool. Now let's talk about functions right after this, what all of this means. But we can return, let's say our LHS.value is equal to our right-hand side dot value. And actually let's do value 2 for this instance, because value 1 is different, but value 2 is the same. So in this case, it should therefore print true. And we're just checking to see if they're equivalent or not via this right here. And this is useful for shorthanding things, right? You don't really want to be typing out dot value 1 is equal to example 2 dot value 2. Sometimes you just want to compare the structures. So this allows you the ability to compare the 2 structures in a way that's shorthanded and very easy to write out, but yet having a complex way of making sure that the values are actually the same. Might be a little advanced, but I thought it would be helpful. Now on the topic of functions, let's talk about how functions are created. It's very simple. You have the function name, and then you open close parentheses into curly brackets. And so basically now if I wanted to call this function, I just say function name, and therefore this function name is called. Let's print something right now, such as name, and boom. Now, when creating a function, we can also pass along values. So let's say, like we did with the initializer, right? We can do things such as name colon string, and now instead of printing name here, we printed out the function name that we passed along. So we can say function name, and let's just put something in there. And now our function name is being provided when we call this function. And again, just like before with the initializer, if you don't want to have this there, you can add a little underscore, and that's going to have that there instead. Or if you want to label it something else, you can do that here as well. Now, also in regards to functions, you might have noticed in the last example that I have an arrow at the end. So this arrow is basically saying when this function is done, I expect there to be something returned. So let's say I want there to be a string that's returned. So that instead of printing this name, I want there to be, let's say, a return of the name. And so now what this does, and it changes this function entirely, is because now this function can be used as a string. So if I wanted to say var string will be equal to that, then I say string plus equals, and then we put our function name like that, this function is now essentially a string. So I'm basically adding a string to a string. So that's the difference here. Now, one last thing that you can do with a function is you can provide this name with a default value. So let's say I want there to be a default, so I don't have to type it out every time, but if I wanted to, I could. So I can say function name, and it's going to be hello. But if I wanted to change it, I could. So I can just say function name, and instead of having a default value of hello, I can change it to something else. And now the function name is going to be something instead of hello. Also, you don't need it to be a specific, oh, I'm going to return only a string. You can also make it return a tuple, right? So we can have it so it does a string and an integer. So now in this return statement, I need to return both the string that we provided it and also an integer that goes along with it. And there you have it. So now if I wanted to, I could say function name, and then we say 0 and 1. And if you wanted to give these specific things a name, so that you don't have to say 0 and 1, you can also, like we did with the tuple previously, say this is the string, and then this is the integer. So now we say dot string. Now another thing with this function name is, let's say I want there to be var name final will be equal to my name, and then I say name final plus equals else. So we provide it with something, and it gives us else back attached alongside it. So now if we return this name final, it should give us that edited value, like so. But let's say I want it to not only return this value, but I want it to edit the original value that I fed it. So if this was my original variable and I fed it inside of here, it's not really changing the example variable. Like if I were to print this out, it's still something, right? It hasn't been changed by the function. But if I want it to be changed by the function, I could. And that's done by adding this. So we add in out string. Now with this, we can't provide it with a default value because we're expecting something to be fed in there. But now if I were to do this and with an in out, it requires you to add the ampersand sign in front of it. It will now change not only the value inside of here, but it'll change the value outside of it. So instead of saying var name final equal name, we can actually just say name plus equals else, and then we return the name. You don't even need a return statement here if you don't really want to. You can just erase those there, and then it's just name plus equals else, and that's that. So we're just adding else immediately, and voila, we're editing this variable, putting it in, adding else, and then sending it out as something else. Now with the functions that we've looked at so far, they're all basically expecting an immediate return value. So the function happens, it's linear, and it happens immediately. But let's say we have to call an API or something that takes us a bit of time outside of the linear function, and we don't really know when things are going to be finished. That's where closures come in.
Always be closing.
So essentially we can say, let me call this my closure function. So inside of my closure function here, we can call completion. And then this is what the closure part is. It's open parentheses, arrow, and close parentheses. Or otherwise, you could call this void. And so now let's say I call API, I do stuff. and then after a certain amount of time, I can now call completion. And so now if I were to call this function, it would look like this. So I say closure function, and then once this is done, we do stuff. Now this right here can be used as a tuple as well, so we can pass along certain values. So if I wanted to pass along, let's say, a string, I can do so. But now in my completion, all I need to do is pass along a string value. And then you'll notice on this end of things, it says contextual type closure argument list expects one argument. This is saying we have a value coming in, and it's not being named here. So basically all we need to do is say a string, or, you know, this is a name in. So we're just naming the variable that we have received from here, and we're putting it here. Now I should note, in giving it this name here, string, we can now just say closure function, and then it should autocomplete that for us. And now if we wanted to print the string that we passed along, which is something, then that happens there. So now we should print out something. As you can see in our console, it printed. For statements are incredibly useful when it comes to programming. Basically what it is let's say we have an array here of 1, 2, 3, 4, 5, 6. You know, we have all of these elements inside of the array, and we want to go through each one of those elements and do something to it, whether we print it out or we add maybe a number to those numbers there. We can do so using for statements. So in order to do that, let's say var array will be equal to, and then we say for I, or this can really be anything. This is the name that you're attaching to that specific element in the array. So for something in array, we want to print out something. So if we were to do that, let's print that out. It's going through it 6 times, and we printed out 1, 2, 3, 4, 5, and 6. Or if we wanted to do it this way, that we say plus 5. You know, then we're adding 5 to each number there, or times 5 if we wanted to do that. You know, this can all be done inside of the for statement if we wanted to. Now, instead of going through an array, there's also other methods of using a for statement. For example, we can use what are called ranges. So the ranges here can be 0, ... less than, and then 4. And what this is going to do is, instead of iterating through an array, which is a set number of things, is then going to start at 0 and end at 3. But it's going to go through it 4 times. So as long as something is less than 4, we're going to go through it, and we're going to add 1 each time. And so now if we were to build and run this, we can do so like that, 0, 5, 10, 15. So we run through it 4 times. Or if we wanted to do it 400 times, you could do it like that as well. Now you can also, instead of saying less than 400, you can make sure that it runs 0 to 400, and you can start at 1 if you wanted to, or stuff like that happens as well. But generally, if you're trying to iterate through an array and whatnot, I typically start at like 0, and then you go up to the certain number. So that's why I type it out that way, and I think most people do in that case. And you can also use this other thing called stride. So let's say from 0 to 100, and then by, let's say, every 5 elements we want to go through it. Then it should make it so we only go every 5 elements. So we're 5, 10, 15, 20, 25, 30, going through all of the different elements. Now, in addition to for statements, there's also a thing called while statements. So if we wanted to do this, we could say while, and generally this is like we iterate through this loop until a certain condition is met. And so in order to do this, we can say, let's say var I will be equal to 0, for example. And then we can say while I is less than, say, 10, then we're going to iterate through this over and over again until we get to that point. So we can say print I, and then we can say I plus equals 1. And the big issue with while statements is you want to make sure that there is a point that the while statement will end. Otherwise, it's called an endless loop and will continue on until your system just crashes. So in order to avoid that, you want to make sure that this part right here is something that can be met at a certain point. You could also, let's say this condition is not supposed to be met, you can also use what's called a break. So what that means is as soon as it hits this breakpoint, it's going to stop this for loop or this while loop. We only printed 0 because we broke through it. And we can even have this so this is a if statement in and of itself. So if I is greater than 5, let's for example, then we're going to break it. Now, why would you write this here? This doesn't make any sense. Obviously, we put this inside of the while statement. That's true. Don't do this. But it's an example. If I is greater than 5, and at that point that it does become greater than 5, then we break it and we end the loop. Switch cases. They're basically like more sophisticated if statements. So what we can do is let's create a variable here. This is going to be our value, and it's going to be equal to, let's say, 2. Then we can say switch, and we're going to say switch on this value that we created, for example. And we can say case. So in the case that our value is equal to, let's say, 1, then we want to run the stuff after this. It's very weirdly formatted, and I think this is very true, but it's case 1 and then colon. Then we're going to run whatever's here. Let's say print 1. Otherwise, we're going to say if the case that it's 2, then we're going to print this here that it's 2. Now, also with a switch statement, if the value is not exhaustive, meaning like it can really be any value and there's no set, parameters, then we also need to add this thing called default. So our default is just going to be, error or something like that. So in the case that our value is equal to 1, we're going to print 1. Otherwise, we're going to print 2. Otherwise, if it's anything else, then we're going to print out error. And that's how a switch case works. So we printed out 2. Now, also something interesting to note here is you can use ranges. So if we have a closed range of, let's say, 1 ... less than 10, and then this is going to be 11, for example, then we can have it so let's say it's 3. We build around this, then it's anywhere inside of this range, so therefore we're printing 1. Or if it's above the range, let's say it's 11, then it's going to print 2. And if it's anything else, it's going to print error. Now let's say I want there to be, okay, this value still happened, but I also want this second case to be called. That's what's called fall through. So if this first value is called, it's going to print, and then it's going to fall through to the next case and also print 2 as well. So we print 1 and print 2. Now you might be asking, why is this useful? Well, it's useful because let's say this value needs to be changed somewhere in this case before it's valid for the next case. Then we can use that. Then we're passing along, let's say, a modified value to the next case in which it can then work properly for the next case. Another thing that we can do with cases, and this is where we get into enums or enumerations. I just call them enums. But essentially what they are is a group of similar typed items. So let's just say our enum, and then let's call this like colors, for example. We're going to have an enum of colors in which we're going to have, case. One's going to be red, one's going to be blue, one's going to be purple, so on and so forth. And then with our enums here, this should actually just be like color, for example, and it should be capitalized. But we say var value, and then we can say it's going to be a type of color, and then we can now say it's going to either be blue, red, or purple. And now we have a limited list that we can go through. So if we say switch, and then we switch through our value, we can say case in the case that it's purple, then we're going to do this. Case in the case that it's blue, we're going to do this. And case in the case that it's red, we're going to do this. And now I don't need a default value as well because we've exhausted the list. And so for this, now if I switch between these different values, it's going to print out, it's going to be purple or it's going to be red. And the nice thing about this is I can also assign values to each of these variables. So if I wanted to convert this purple into a number or a string or a color in and of itself, I can do that. And in order to do that, I say enum color colon, and I want to say we're expecting, let's say, a string out of this. Now what this allows me to do is I can say case red will be equal to red, case blue will be equal to blue, and case purple will be equal to purple. And now if I want to, instead of printing out this, I can say print out my value dot raw value. So what this raw value here is, it's grabbing this right side of things. It's grabbing the red, it's grabbing the blue and the purple. And we know that raw value here is a string in this instance, but it can also be attributed to integers or any other type of class that you want to assign to this enum. But this way, you don't need to rewrite code so often. You can reuse this stuff in many other places. Now, also just another quick little thing that you can do. If I wanted to create a color off of a raw value, I can do that by saying color raw value. And if I wanted it to be red, you can do that, and it's going to grab one of these and create it correctly. And this is optional at the moment because it doesn't necessarily know that this string here is going to reference any of these strings here. So you can also have something to fall back on. And so in order to have something to fall back onto, you say question mark, and you can set it to a default value of purple. And if you were to build and run that now, it's red. But if I were to type this in wrong, it's going to default to purple. And that's generally how optionals work as well. Now, in addition to enums, you can also do something where you can attach an enum to a specific error. So for instance, let's call this my custom errors. And then we're going to assign this to an error instead. And let's just give this a couple cases. Let's say canceled, error, wrong input, or something like that. You know, something maybe a bit custom. This is where we can create a function. Let's just call it example. And then we want to specify that this function throws. And so now let's say if, you know, something goes wrong in our example here, we can say if, let's say 1 is not equal to 2, then we can throw, let's say our custom error dot canceled, or there was wrong input or something like that. Then when we call this function, we can no longer call it normally like example. This is where we need to call what's called a do, try, catch. So we're going to do the stuff that's inside of here. We're going to try running this function, and then we're going to catch. So after this do, we're going to try catching whatever error comes through. So I can just say print error. And so what this means is if I ran this, something came back, it's going to print wrong input. And so this can be useful instead of writing out, you know, custom errors all the time. You can just create one error that is universal and used throughout your application that you can revert back to when using documentation, for example, knowing exactly which error applies to which case and being able to fix stuff. Extensions are incredibly useful if you want to expand upon a class that already exists. So in order to do this, we can say extension, and let's say I want there to be, you know, an extension on my integer. So instead of maybe, you know, previously you maybe want to create a class that has a few custom integers and you assign those integers and whatnot. But the unfortunate part of creating a custom class is now you have to refer back to that custom class. But in this case, we can basically just call the original class that's built in with Swift. You can extend upon your own custom classes if you want to, but this is what I find as the most important part of using extensions. So if I extend upon an integer here, I can say static, which basically means it's going to stay as is inside of the code and will not be changed, basically. Then we could say let distance equal, 1,000. And so now if I wanted to access that, I can just say print my int dot distance. So boom. Now my integer has something attached to it already called the distance. Or let's say I wanted to create another function on top of this. I create a function that calculates distance for me. So I can say calculate distance, in which let's have this return maybe an integer. And so what this can do is now this is an extension on an integer. So I can say return maybe self times 1,000. And so what this means is self is referring to the integer that I provided on. So I can literally just say 1,000 dot calculate distance now. And it's going to calculate whatever distance or, whatever this function is doing and spit it out correctly. So this is going to be 1,000,000. Now, of course, this can be useful for any of your own custom classes if you want to use it in that way, but it's a way to extend upon a class that's already there. And, you can write these functions out like normal functions as you would with different parameters and whatnot. Just a small tidbit here. If you want to add some spacing or like characterization in some of these numbers here, so for instance, let's say I type out 1,000,000 and you can't tell that it's 1,000,000, then you can add underscores instead to make sure that it's like 1,000,000 and people know that it's 1,000,000. These underscores do nothing to affect the number itself. It just for legibility purposes. Or I guess this is 1,000,000,000, but whatever. And so basically what a protocol is it makes sure that whatever class we're creating has specific functions or elements built into the class that we're building. So let's say my protocol will be, my class protocol. This is generally what I do. We say class protocol. We want to make sure that our class protocol has maybe this certain variable, and it's going to be an integer. And then we also wanted to make sure that this specific class has a specific function. Then we can write it out this way. And also with this, you can limit access. So you can say, for instance, that this integer here is only a get property, or you want it to be a get set. You can change that as you want, but a get property basically means I can get this variable from this class, but I cannot change the variable that's on the class. So there's many important reasons to actually use protocols, but this is definitely one of them where people can't mess around with other people's code. So if we want to take this class protocol and attach it to maybe like an example class here, we can say class protocol. And now if we were to build around this, it's going to throw an error saying we need these functions in there. So we want to make sure that var example, we set that, and then our function name, it's already built into it as well. And so it therefore conforms to the protocol that we created. And with all this said and done, I think Swift is a very easy programming language to learn. And I think, hopefully this gave you a good basic starting point to get you building some applications. Now, in doing so, I think, this is a basic starting point. You now know how the fundamentals are working in the application. The hard part of Swift programming is when it comes to frameworks. So working with Swift UI, working with social maps, and all of these other frameworks that make the app an app, UI kit, for example, that's where the hard part comes in. And that's where your journey really begins. So hopefully you found this helpful in some form. And I wish you all the best on your journey and that you build your app. So I'll see you in the next one.